Low Voltage Breaker Course Section 12. Installation and Maintenance, Safety and Longevity. LOTO and Preventing Heat Failure. Welcome to the final section of Circuit Protection Essentials. We conclude our course by covering the best practices for installation and maintenance, ensuring the longevity of your breakers and the safety of personnel. Safety Protocol, LOTO. The number one rule when installing or performing maintenance on any breaker is safety first. Always use Lockout Tagout, LOTO, procedures. This involves physically de-energizing the circuit, locking the switch open, and placing a tag to prevent accidental re-energization. The danger of loose connections. The most frequent cause of breaker failure, wiring degradation, and nuisance tripping is simple, loose connections. A loose terminal creates high resistance, leading to excessive heat generation, even under normal operating load. The importance of torquing. To prevent this overheating, all terminal screws must be tightened to the manufacturer's specified torque setting. Using a torque screwdriver or wrench is not optional. It ensures perfect contact and prevents both under-tightening, heat, and over-tightening, terminal damage. Thermal management. Circuit breakers are sensitive to ambient temperature. If a panel is poorly ventilated or overloaded, heat can build up and cause the thermal trip unit to operate prematurely, a common source of nuisance tripping. Proper ventilation is a crucial part of breaker maintenance. Periodic inspection. While breakers are designed to be reliable, they aren't maintenance-free. Conduct periodic visual inspections to check for signs of failure, discoloration on the breaker body, melted insulation near terminals, or a burnt smell inside the panel. Post-fault assessment. If a breaker has tripped multiple times due to severe faults, like a major short circuit, it should be treated with suspicion. The extreme forces of arc interruption can damage the internal contacts, reducing the breaker's ability to clear a future fault safely. Testing the trip. For safety devices like RCCBs, RCDs, and GFCIs, a test button is mandatory. This button simulates a fault condition and confirms the mechanical trip mechanism is still operational. These devices should be tested routinely, often monthly, as specified by the manufacturer. Replacement criteria. Never attempt to repair a damaged breaker. If a breaker shows signs of internal arcing, has a weak spring mechanism, or has failed to interrupt a fault within its car rating, it must be replaced immediately with a new, correctly rated unit. Comprehensive protection strategy. The installation of a circuit breaker is the last link in a chain that includes correct wire sizing, proper coordination, and selecting the right protection type, MCB, RCD, AFCI. All these elements must work together for a safe system. Your role as the guardian. By understanding the fundamentals of fuses versus breakers, the types of faults, the different breaker technologies, and the importance of precise installation, you are now equipped to be a true guardian of electrical safety. Conclusion: a safer system. Thank you for joining us for this course. We hope this guide has provided you with the foundational knowledge to design, select, and install reliable, high-performance circuit protection in any low-voltage environment.